Welcome everybody. It's Chandra from CIVIL-MECH-MATHS concepts, and in this lecture I will be detailing about trigonometry, compound angles. In the tricks of trigonometry, I will be talking about trigonometric compound angles and finding the different angles in addition to 0, 45, 30, 60 and 90 degrees. How to find out sine 15, sine 75, sine 135 and similarly other similar trigonometrical identities. And also we will be discussing about sine 2 theta, cos 2 theta, tan 2 theta, sin A plus B, cos A plus B, tan A plus B, cosecant A plus B, secant A plus B, and we will extend this to sin 3 theta and others. Now, for example, sin theta is equal to opposite side by hypotenuse. That is equal to, let us draw a right angle triangle with vertices ABC, where sin theta is equal to opposite side by hypotenuse is equal to BC by AC. Next, let us define cos theta, that is equal to adjacent side by hypotenuse, that is equal to AB by AC. Tan theta is equal to opposite side by adjacent side, that is equal to BC by AB. Here in cos theta there is a small error, it is AB by AC. While writing I have written it wrongly. Now it is tan theta is equal to BC by AB. But we know the identity relation sin square theta plus cos square theta is equal to 1, and similarly and cot theta. Now, whenever theta is less than 90 degrees, these are all defined as positives. And let's go for another triangle ABC, in which we divide the angle theta into two parts, one as theta 1 and another as theta 2, and the vertices as A, B, C, and we will put for theta 1 the intercept as C dash. If theta 1 plus theta 2 is equal to theta, let us say, that means theta we have divided into two parts, theta 1 and theta 2. BC we have divided into two parts, BC dash and CC dash. Here, if theta 1 plus theta 2 is equal to theta, let us say, then sin theta is equal to sin theta 1 plus theta 2. Replace theta with theta 1 plus theta 2. That is equal to opposite side by hypotenuse, that is BC by AC. Sin theta 1 plus theta 2 is equal to BC by AC. Now, let us see. We will further divide the values one by one. BC is equal to BC dash plus CC dash, and AC is hypotenuse. AC is same for every angle. Here, sine theta 1. Sine theta 1 is nothing but BC dash by AC dash. That is hypotenuse by this opposite side by hypotenuse. Sine theta 2. Sine theta 2 cannot be found from the simple Pythagoras theorem because ACC dash is not a right angle triangle. Now, let's further look in depth. Sine theta is equal to BC by AC. We know that. Sine theta 1 is equal to BC dash by AC dash. We have that value also. Then how to find sine theta 2? Then, for defining theta 2, we have a equation is called sine theta 1 plus sine theta 2. Sine theta 1 plus theta 2 is equal to sine theta 1 into cos theta 2 plus cos theta 1 into sine theta 2. This is the most important equation. Please remember this. This should be remembered. Very important equation. Sine theta 1 plus theta 2 is equal to sine theta 1 cos theta 2 plus cos theta 1 sine theta 2. Please remember this. It's very, very important. Please remember this. Here in this equation, for example, theta 1 and theta 2 are replaced by a plus b. Sin a plus b is equal to sin a cos b plus cos a sin b. Usually in this form, in the textbooks, the formula is written. Either you can say sin theta 1 plus theta 2 is equal to sin theta 1 cos theta 2 plus cos theta 1 sin theta 2, or sin a plus b is equal to sin a cos b plus cos a sin b. Both are same. Now, in these equations, sin theta 1 is known to us, sin theta is known to us, and since theta is equal to theta 1 plus theta 2, we have written sin theta 1 plus theta 2 is equal to sin theta. Sin theta is equal to sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. Sin theta is known. Sin theta 1 is known. From sin theta 1, cos theta 1 can be found out. It's square root of 1 minus sin square theta 1. Similarly, cos theta 2 can also be expressed cos theta 2 is equal to 1 minus sin square theta 2. That means when we convert everything into sin theta 2 form, we can find out sin theta 2 from the equation sin theta 1 plus theta 2 is equal to sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. This is very, very, very important relation, and as a homework, I want you to prove the above identity geometrically. I have given a hint about analytical solution. Please try to prove geometrically. Then you will have a clear understanding of the trigonometry. You have to not only to see my videos, it is better take notes out of it and prove the theorems on your own. Now, for example, sine A minus B can also be possible. Then we'll write sin A plus or minus B, let us say, combined formula. Then it is written as sin A cos B plus or minus cos A sin B. Whenever there is a plus on the left hand side, there is a plus on the right hand side. Whenever there is a minus on the left hand side, corresponding minus is there on the right hand side. This is a very, very, very important formula for relating compound angles and trigonometrical identities. Sin A plus or minus B is equal to sin A cos B plus or minus cos A sin B. Similarly, let us write for cos A plus B. Cos A plus B is equal to cos A cos B minus sin A sin B. Similarly, cos A minus B is equal to cos A cos B plus sin A sin B. Please try to understand the signs. When on the left hand side for cos, if it is a plus sign, on the right hand side there is a minus sign. On the left hand side for cos compounding angle, there is a minus sign, there will be a plus sign on the right hand side. This combined formula can be written as cos A plus or minus B is equal to cos A cos B minus or plus sin A sin B. This minus or plus comes on the right hand side when there is a plus or minus in the left hand side. That sequence should not be broken. Please remember that. This is a very important identity relation as far as cos theta is concerned. First one was sin theta, second is cos theta compound angles. Sin A plus or minus B is equal to sin A cos B plus or minus cos A sin B. And cos A plus or minus B is equal to cos A cos B minus or plus sin A sin B. Now we will go for tan. Tan A plus B is equal to sin A plus B by cos A plus B. Because sin theta by cos theta is equal to tan theta. That is equal to sin A cos B plus cos A sin B whole divided by cos A cos B minus sin A sin B. This can be written finally in the form after applying required algebra in trigonometric identity relations. This tan theta, that is tan A plus B, we have to write in terms of tan A and tan B. Tan A plus B is equal to tan A plus tan B whole divided by 1 minus tan A tan B. This you try to prove by using your algebraical knowledge. This is also very, very important formula. This you prove as a homework. Sin A plus or minus B, I have given cos A plus or minus B, I have given tan A plus or minus B, I have given. These are the three important formulae. Here we have seen for tan A plus B. Now we will go for tan A minus B. Tan A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. You please try to understand. When there is a positive sign in the left hand side in tan compounding angle, there is a positive sign in the right hand side numerator and negative sign in the right hand side denominator. When there is a negative sign in the tan compounding angle, there is a negative sign on the numerator and positive sign in the denominator. You see here tan A plus or minus B is equal to tan A plus or minus tan B divided by 1 minus or plus tan A tan B. This is a very, very, very important formula which you are required to remember. Now I have given three formulas. Sin A plus or minus B is equal to sin A cos B plus or minus cos A sin B cos A plus or minus B is equal to cos A cos B minus or plus sin A sin B. You please remember the reverse of the signs. Tan A plus or minus B is equal to tan A plus or minus tan B divided by 1 minus minus or plus tan A tan B. These are the three important basic formulae for compound angles. Whether you add or whether you subtract one angle from another, then the values of sin theta, cos theta and tan theta of the converted angles is given. As a homework, write equations for secant A plus B, cosecant A plus B and cot A plus B. These things, these three equations, their derivations and their implications for secant, cosecant and cot and deriving them, that gives a lot of knowledge, lot of basic knowledge in trigonometrical identities for you. Let us find out certain conditions. Let us apply certain conditions. If A is equal to B, that is equal to theta. If angle A is equal to theta and B is equal to theta, then sin A plus or minus B is equal to sin theta plus or minus theta. That is equal to sin theta cos theta plus or minus cos theta sin theta. That implies sin 2 theta is equal to then sin theta minus theta. These two values it will be given. Sin theta minus theta is equal to sin 0. Sin 2 theta is equal to sin theta cos theta plus cos theta sin theta. That is equal to 2 sin theta cos theta. Then sin theta minus theta is equal to sin 0 is equal to sin theta cos theta minus cos theta sin theta. That is equal to 0. From these two values, it implies that Sin 2 theta is equal to 2 sin theta cos theta and sin 0 is equal to 0. It's a beautiful derivation. Please remember this. Very good derivation. Next, we'll go for cos. Cos A plus or minus B is equal to cos A cos B minus or plus sin A sin B. This implies if we assume A is equal to B is equal to theta, then cos theta plus theta, theta plus or minus theta we can say, cos theta plus theta is equal to cos 2 theta, cos theta minus theta is equal to cos 0. These two imply cos 2 theta is equal to cos theta into cos theta minus sin theta into sin theta, that is equal to cos square theta minus sin square theta, and cos 0 is equal to cos theta plus cos theta into cos theta plus, you remember the sign plus, sin theta into sin theta, that is equal to cos square theta plus sin square theta, that is equal to 1. From these two, we derive that cos 2 theta is equal to cos square theta minus sin square theta and cos 0 is equal to 1. It's also very nice expression. Please remember this. Next, we'll take up tan. Tan A plus or minus B is equal to tan A plus or minus tan B divided by 1 minus plus or minus or plus, it should be tan A tan B. It implies if A is equal to B is equal to theta, then tan A plus B is equal to tan theta plus theta, that is equal to tan 2 theta, that is equal to tan theta plus theta divided by tan theta plus tan theta divided by 1 minus tan theta into tan theta, that is equal to two tan theta by 1 minus tan square theta. Just see, tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. Similarly, for tan A minus B, that is equal to tan theta minus theta, that is equal to tan 0, that is equal to tan theta minus tan theta. Don't forget the signs. 1 divided by 1 plus tan theta into tan theta, that is equal to 0 by 1 plus tan square theta, that is equal to 0. 0 divided by something is always 0. That implies tan 2 theta is equal to 2 tan theta by 1 minus tan square theta, and tan 0 is equal to 0. This is also very important equation which you may have to remember. From the beginning, let us see what we have done. These are all very important. Sin theta 1 plus theta 2 is equal to sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. Sin A plus B is equal to sin A cos B plus cos A sin B. Similarly, sin A plus or minus B is equal to sin A cos B plus or minus cos A sin B. And cos A plus or minus B is equal to cos A cos B minus or plus sin A sin B. And in sin A minus B, if you want to expand alone, sin A minus B is equal to sin A cos B minus cos A sin B. Then, from the above, we can even write, we have found out what is the value of tan A plus B from basic definitions. And then, we'll move on to tan A plus or minus B. That is tan A plus or minus tan B by 1 minus or plus tan A tan B. And these are the important three equations for compound angles we found out. And homework is given for finding for secant, cosecant and cot also for different compound angles. Then by putting A is equal to B is equal to theta, we have found sin 2 theta, then sin 0, cos 2 theta value and cos 0. And these values we have found. And these values are written. Sin 2 theta is equal to 2 sin theta cos theta, and sin 0 is equal to 0. Cos 2 theta is equal to cos square theta minus sin square theta, and cos 0 is equal to 1. Then we moved on to tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta, and tan 0 is equal to 0. Now, we'll write the final equations of sin 2 theta as 2 sin theta cos theta. Cos 2 theta is equal to cos square theta minus sin square theta, and tan 2 theta as 2 tan theta divided by 1 minus tan square theta. Then as a homework, I want to give and ask you to derive expressions for sin 3 theta, cos 3 theta, and tan 3 theta. I will give a hint. For solve for sin 3 theta, you solve for others. Hint is sin 3 theta is equal to sin 2 theta plus theta, because 2 theta plus theta is 3 theta. That is equal to sin 2 theta cos theta plus cos 2 theta sin theta from the definition of sin A plus B. That is equal to 2 sin theta cos theta into cos theta plus cos square theta minus sin square theta into sin theta. These are all from the previous derivations which we have done. That is equal to 2 sin theta cos square theta plus cos square theta sin theta minus sine cube theta. That is equal to 3 sine theta cos square theta minus sine cube theta. These are all derivations we can do for anything. Sine 4 theta you can find, sine 5 theta you can find, sine 10 theta you can find. That means you can expand this knowledge to cos also, multiple thetas, and tan also, tan 2 theta, tan 3 theta. For sine theta, it is sine A plus B we have used. For example, there are three angles, sine A plus B plus C. That equation can be written as sine A plus B plus C is equal to sine A cos B cos C plus cos A sin B cos C plus cos A cos B sin C minus sin A sin B sin C. This is also very important formula. You try to prove it from the textbooks. You read on this and try to prove this. This is, I want to give it as a homework. Now, we'll move further. On the same topic, we'll move further. We'll take some example, which is a typical angle. We know the values of sine 45, cos 45, tan 45. We know the values of sine 60, cos 60 and tan 60. Now we will go for the example to find the value of sine 15 degree. It may look typical, but we will do it very easily. You please see. The solution can be, what is the value of 15 degrees? 15 degrees is nothing but the difference between 60 degree and 45 degree. 15 degrees is equal to 60 degrees minus 45 degrees. That is equal to A minus B. We'll write it as A minus B. What is the value of A? A is 60 degrees, B is 45 degrees. Then what is sin A minus B? We'll use that formula. Sin 15 is equal to sin 60 minus 45. That is equal to sin A minus B. That is equal to sin A cos B minus cos A sin B. That implies here A is equal to 60 degrees and B is equal to 45 degrees. Then this implies sin 15 degrees is equal to sin 60 degrees into cos 45 degrees minus cos 60 degrees into sin 45 degrees. We know the values of sin 45, cos 45. We'll substitute them. Sin 60 is root 3 by 2. Cos 45 is 1 by root 2. Then it becomes root 3 by 2 into 1 by root 2 minus cos 60 is 1 by 2, sin 45 is 1 by root 2. Then it becomes 1 by root 2 is taken common, root 3 by 2 minus 1 by 2, that is equal to 1 by 2 root 2. If 2 root 2 is taken common, in the bracket root 3 minus 1. This is the value of sin 15. How simply and how easily within seconds we could find the value of sin 15. Please appreciate this. Now, can we extend this concept to other degrees, other angles, which by chance are asked in the examination, for which you do not remember the values, like sin 45, cos 45, tan 45, sin 30, cos 30, tan 30, sin 60, cos 60, and tan 60? In those times, whenever any angle is asked, you can derive from these compound values or compound equations provided to you. And as homework, I want to give you some values. I want you to calculate some values which are very, very important from the point of view of RRB NTPC, because one value of tan 300 was supposed to be calculated in one of the problems which I have given you previously in my previous lectures. Now, find out the values. It is your homework. Cos 75 degrees, sin 75 degrees, tan 75 degrees, tan 300 degrees, sin 300 degrees, cos 300 degrees. Then try to find out sin 135 degrees, cos 135 degrees, tan 135 degrees, sin 225 degrees, cos 225 degrees, and tan 225 degrees. These are all given for your practice. Please don't only see the video. Please try to understand the concept. Make a habit to practice to calculate for different angles the value of sine, cos, and tan. Now, in the above problem, I have calculated the value of sine 15. For other angles, can you please calculate? You do the homework, find cos 15, tan 15 degree, secant 15 degree, cosecant 15 degrees, and cot 15 degrees. Try to find these values. These may look simple, but please try to get the values. Not only for these, you try to get the values for secant, cosecant, and cot also. For all the values I have provided to you, 75 degree and 300 degree, 135 degree, 225 degree, so that this will increase your practice, and once any question is given in the examination, you will be able to easily remember whatever you have done as a homework, and you will be able to find out the alternative very easily, and you will be able to score high in the examination. Please do mathematics. Please don't listen to mathematics, and please don't see mathematics. Doing mathematics is only the solution for scoring high in mathematics. Do have mathematics, do mathematics, do mathematics. There is no shortcut for mathematics. Do mathematics. And again, this is Ramachandra from CIVIL-MECH-MATHS concepts, and feeling that By doing mathematics, you will score high in the mathematics examination. Please kindly do the mathematics along with me. I'll do some questions and whatever I give the homeworks, please do in the as an exercise and complete them and comment in my comment box. I will definitely correct your answers and give you solutions for them. Best of luck to everybody. Please do not stop viewing and reviewing my lectures and comment them. For any doubts, I am